So the first question on the homework this week was, f of x is 4x squared plus 9 over x squared. Solve the equation f of x is 13. The language to start with here is a kind of a problem to get over, but all it means is it's an awkward and irritating way of saying 4x squared plus 9 over x squared equals 13. That's all that's going on. It's just trying to get you to that point to start with. This is an equation where we've got an unknown on the bottom of the fraction. So the next thing we want to do with that is to multiply everything by the unknown. So we're going to multiply everything by x squared. That will give us 4x to the 4 plus 9 is 13x squared. So eventually we get an equation that looks like that. Now at this stage, we had been doing some, what do you call them? Substitutions, that's it, of different things. There was one in the test last week where we had to do a substitution for x plus 2 or something like that. So the same idea here. We'll use t is x squared. We don't have to write this down, but sometimes it's helpful for us to be reminded that means that t squared is x to the 4, so we've got 4t squared minus 13t plus 9 is 0, which we want to now try and factorise. It's a slightly harder kind of factorisation question. If we multiply the 4 and the 9, we get 36. Now, would that work? Are there any things that multiply to give 36 and add to give 13? 36 is 9 and 4, isn't it? So that's, we've got 4t squared, we've got minus 9t and minus 4t would give us, sorry, that should be 36 there, shouldn't it? That would give us the 36 that we wanted. And so we're going to write it being 4t squared, how did I write it? We'll write it like that. We've got not much going on in terms of common factors. Common factor of t, common factor of minus 1. Giving us the factor 4t minus 9 and the other factor t minus 1. 0, two things multiplied together, one of which must be 0, so either t or 4t minus 9 is 0, which would give us 4t is 9 and t is 9 quarters, and this one gives us t equals 1. But it wasn't about t, it was about x. T was equal to x squared, so x squared is 9 over 4, and x squared is 1. Square root gives us x is plus or minus 3 over 2, and this one gives us x is plus or minus 1. We have 4 answers. The answers are minus 3 over 2, minus 1, 1, and 3 over 2. I don't mind if you've written 1.5. I don't mind if you haven't written them out in ascending order like that. I just want to see the 4 answers that are there. That was for quite a lot of marks, wasn't it? 5 marks for working way through that. Okay? Remember, if you get to this stage here, and it didn't happen in this case, but if it had worked out that one of these is negative, when you get to the point of saying x squared equals something negative, you must write no real solutions. If x squared is equal to a negative amount, there are no real solutions for that. Don't just plough on regardless, square rooting a minus number. Question 2, sketch the curve that is given there. Well, the great thing is this factorised form tells us the roots of this equation. So what we can start by doing is saying if y equals 0, we're left with x plus 1, x minus 2, 4 minus x equals 0. And that would have roots that would have solutions of x is minus 1, x is 2, and x is 4. That last one there. We would also have to have a look at what happens if x equals 0. If x equals 0, then y equals 1 times minus 2 times 4. 1 times minus 2 times 4 is negative 8. So we've ended up with a graph that crosses at -1, 2 and 4, and also at -8. And now it's joining the dots. Now if we really want to, we can think if you multiply this out, you get a negative coefficient of x cubed as well, wouldn't you? Because that would be the first term that you got, x times minus x. So a negative one will go like that kind of pattern. If we join it up, trying to go as best we can through those points. I'm not particularly happy with that curve there, but that's the basic shape that we'd have. It did say showing the intercepts with all the axes, so we're going to mark that as being -1, 2, 4, and that's -8. There we go. 4 marks for that. I would want to give you 1 for the basic shape, and then probably 1 for each intercept, near enough. Something along those lines. There were 5 intercepts, so only 4 marks there, aren't there? I mean, there were 4 intercepts. Anyway, you know, 1 for the basic shape, 1 for getting the x-intercepts right, 1 for getting the right y-intercept, and the final mark for everything being largely correct. That seems better. Okay. This question is the one that we got you to change the question on the sheet. Did everybody remember to do that? Because originally John had written the wrong, or Paul had written the wrong equation in that bit. I shouldn't have mentioned that live on the video, that it was Paul who did that wrong. But it could have been anybody. It might not have been Paul who wrote the wrong equation there when he was typing it out. Okay, I think I've got away with that now. On one set of axes, sketch the curve y equals 1/x and 6x minus 1. Oh, not a great set of axes. 1/x is one of the standard graphs that we know. It's up on the wall from John's display. It looks a bit like that. So there's our graph of y equals 1/x. We ought to label it. Make sure you don't find yourself doing what I did there and curling down at that point, or touching the axes or doing anything like that. 6x minus 1 is a straight line, quite steep, passing through -1. So we want to have a straight line doing something like that. Well, that's -1. And that's probably enough, isn't it? So we see from the graph that we've got 2 points of intersection. Okay, I ought to label my axes as well. That was y, and that point was x. Find the coordinates of the points where the two things intersect. We can see there are 2 answers. What's this heading towards? What do you think we're going to end up here with? Simultaneous equations. It's going to turn into a quadratic eventually, isn't it? Because we're going to get 2 answers. So let's try it. In part 2, we're going to have the point where they intersect is where y is 1/x and y equals 6x minus 1. The easiest way to solve this is just to do a substitution to eliminate y. If we put these together, we've got 1/x is 6x minus 1. We've again got an unknown on the bottom of our fraction, so we're going to multiply everything by x. To give us 1 equals 6x squared minus x, so that gives us 0 is 6x squared minus x minus 1. This is, hello, we're just doing a video of some maths, but everybody's here. Yeah, we're recording it with a little
okay.
Yeah.
They won't see me, they will.
No, it's all right.
That's
And
okay.
I would edit that out if I knew how to do that.
Right, okay.
We're all
so
here.
I should probably go. Right.
That's going to have to stay in because I don't know how to edit things out. I don't even know how to edit out the bit where I say I don't know how to edit that out. So that'll have to stay in. I better carry on. This is quite an easy thing to factorise, this, isn't it? We're just going to have 3x and 2x oh, hang on, that needs to be plus, doesn't it? And that's minus, is that right? 6x squared minus 3x plus 2x is minus x minus 1. So x equals negative a third, and x equals a half. Does this feel like a sensible answer, given that we drew a graph? Well, it does, doesn't it? It looks like one of the roots is negative and the other one is positive, and that one looks a bit closer to the y-axis than that one did, so it's looking okay. The question said, find the coordinates, so we're not there yet, are we? What do we have to do to finish it off? Find out the y value, the other bit. Y was 1 over x. The other one would be just as easy to work out, but we'll go with that one. If x is minus a third, y would be 1 over minus a third. If you divide by a fraction, you multiply by its reciprocal. So 1 over minus a third is equal to negative 3. And the other one, if x equals a half, that implies that y is 1 over a half, which is 2. And I want to write my answer in a sensible way. And it looks like that. And there we are. Okay. Looking around, it looks like that caught a few people out, did that last bit. Finally, last one. Some Year 12 students, like you, took a general studies examination. The results are illustrated in the box and whisker plots. We've got the females there and the males there. Give 2 comparisons between the overall performance of the females and males in the general studies examination. We need to be specific about the things that we are writing here. This isn't looking for the females did better. That's not the kind of thing that we're after here. We're after specific things. So, what could we say? The females had a higher median score. That would seem like one good comparison. It's going to be a comparison, so we're going to write the females had a higher median score than the males, because remember we're doing a comparison, and we could try and give some figure, so that's round about 51 compared to the females, which looked about, the males, sorry, which looked about 45. Something like that. Another comparison that we could make, the male scores were more spread out, or had a greater range than the female scores. The males had a greater range of scores. Than the females, and we could probably give a figure for that, something like 78 minus 10, so 68 compared to, what's the female one, about 70 and about 12, so that's about 58. Something of that kind of order. There are other things we could say. The interquartile ranges actually look fairly similar, don't they? I'm not sure there's an awful lot in that. We could say the top score by the females was lower than the top score by the males. That would be a comparison that we could make. So there are quite a few things that we could put in there. But it needs to be specific. So you need to be referring to a particular thing in the graph. It's not enough to make a generalization to say something like the males are better, or the males are much worse, or something like that. You know, you've got to be specific. Part B, give one advantage and one disadvantage of using box and whisker plots rather than histograms to display the results. Can anybody think of an advantage of using box and whisker?
You can see the ranges, the quartiles and the median better with a box and whisker plot.
Okay, so a box and whisker plot allows you to quickly see the median, quartiles, and the range. So that's a definite advantage of a box and whisker plot. What about an advantage or disadvantage of a box and whisker plot? Advantage of a histogram. What does a histogram do that a box and whisker plot doesn't in the same way?
Can't see the frequency.
Okay, that it allows us to see more detail about the frequencies within the distribution. So the box and whisker plot of the spread of the data, the spread of the frequencies between the quartiles. Do you get the idea of this? That with the histogram, you're going to see more detail because the groups are probably really close together. Really, this is kind of giving you, that band is 25%, that band is, that band is, and that band is. Split it into 4 groups of 25% each, really, whereas the histogram will show us more than that. That was another 2 marks at the end of that. Oh, and that's the homework for this week. Oh, yeah, and that's maths.